In between videos, I decided to add a little bit more functionality. So we have our ability to stop. I added a function for setting the direction, where the user can pass in a direction, and I renamed this to set PWM%. I realized that we weren't actually setting the direction in here anywhere, so it was a little bit wrong to call it set speed forward, because if it had already been set to reverse and I had set the PWM%, we wouldn't be going forward. We would have just been going at that percentage in whichever direction the motors were already set. In fact, it would have had it spin in place if one was set to forward and one was set to reverse. So instead of adding a direction into here, I just added a second function for set direction. And that's not currently being set anywhere. So I can do that here in the constructor. In the setup function. And let's call this direction and set it to forward. So now the way you read this is inside the setup function, I'm going to set it to forward at 50%, and it will go at that speed as long as it's enabled. The second is it's disabled, we will stop the motors, and since no other code is running in the loop, they'll never actually run. So this is probably a good place to add a member variable. In fact, one for each of the motors that sets the current speed, and it'll re-enable the speed if we get communication back. That's one method of doing this, and that's the way that we'll play around with doing it for now. Let's call it the left PWM% and the right PWM%. And now that we have those, we need a constructor to initialize them. So inside of our constructor, we can initialize those both to 0. And we don't really need to do anything else in our constructor. Those are just values that we'll keep around. And now we need to hold on to them. And now that I look at this, I think it might be a mistake to hold on to the PWM% instead of the duty cycle. I think what I'd like to do is hold on to this value that's already been checked, so it's already been constrained and mapped. So let's instead call this the left duty cycle. And likewise call this the right duty cycle. So those are the user-specified values, and we're holding on to them as member variables. They get initialized to 0, and now inside step, if we are enabled, if we're not enabled, we'll say stop, and if we are enabled, we can set these PWM duty cycles. And this might be a good place to do a refactor, now that I have these two lines of code showing up in two places, down here and above, and have a function where I just pass in the two duty cycles and it sets them. I'm not sure if that refactor is worth it though, so I'm going to skip it for now, and if it feels like we're calling that in multiple places or doing these two lines of code in multiple places, then we will go ahead and refactor that into a different place. So to summarize, what we've done now is if the user says they want the robot to go 50% speed, and we are enabled, it'll go 50% speed. And then if we become disabled, it'll stop due to the call to stop here. But then if later on the communication is re-enabled, communicator will be enabled again. And since we remembered the last speed that the user wanted it to go at, that'll get picked up here in the else statement and it'll start moving again. So I should be able to send a command. It'll run for however long the heartbeat timeout is, so by default a second. And if I stop sending them, it will stop, and then if I restart sending heartbeats again, it'll start moving again. It's arguable that maybe it would be better just to leave it in the stopped or halted state and never pick up speed again if communication is reestablished. It might be confusing if it stops and then starts and then stops and starts, and you're not sure if that's a bug in your logic or a bug in the WebSocket communication going back and forth. I'm going to make a note here. Maybe what we really want is for the user to say if there's a disabled, if WebSocket communication is disabled, then they need new commands being sent from the user. But for now, this will be better for a demo, having this code inside here. You know, I'm just uncomfortable with that. I think it's better to just do that now and essentially remove this code from here, and if we're disabled, we go into a stop state. That seems and feels better to me. And then we just manually handle that here somewhere. An else condition, something like this. This is going to be a bit ugly until I figure out a better way to do this. But what I think I'd like to do is to say if WS communicator is enabled, it's complaining because I'm not putting parentheses in the correct spot. So if we are enabled, I'm going to do something to set the duty cycles for the motor. I'll probably just call set direction, or set PWM%. Makes more sense. So we'll put that there. If we're enabled, we will set the %. And then technically, we can just leave this code as is. So if we're not enabled, this will never run, and instead this code will run. Actually, it'll run every time. And if we do happen to be disabled, we will stop the motors there. And they won't be re-enabled unless we have this trigger. That's a little unclean. That might be due for a refactor, but I think I like that better than the previous version that I had, where I was putting that code inside loop step. But I think that's in good enough shape to test it inside Arduino. So now that my board is connected, I should be able to find the board and the port. And I'm realizing now some of that's behind the screen, sorry. And now I will upload our program. The program compiled and uploaded fine. Our microcontroller is running. It connected to Pomona and it's telling me the IP address. So now we can try our wscat command to see if we can send any heartbeats. Alright, so we're connected and I'm getting a message from the Arduino board in the background. So the board is saying client connected and it's giving the IP address of my laptop. Now I can send a message and it says it received the message. The motors didn't do anything because I didn't send a heartbeat, and a heartbeat is the only type of message that's going to set the enable flag. So I sent a heartbeat. It ran, and I had a timeout, but the motors didn't move. And that's because I don't have the switch turned on to the motors. Alright, the motors now have the switch turned on. And if I send a heartbeat, they go forward. Actually, to me, yeah, they're going in reverse. So I have an error in this line of code here. So for the way that I have our wiring set up, I'll need to switch those. And I'll do that after the fact, so I'm not using time here. So if I continue to send heartbeats, I can continue having the motors run. That's a little tedious to do it this way. Another step better would be to automate that process. So this is a simple fish command which every 0.9 seconds will send a number. Let's see if that works. If I plug in the correct WebSocket. We're sending the commands every second, 2 through 10. And then our client disconnected. What happens if we change that from sending numbers to sending the word heartbeat? The motors will run until we stop sending heartbeats.